Hi friends, this is Kishore. Today I am going to tell you about the simple understanding of power factor. What is kilowatt, what is KVA and what is KVAR. How power factor impact your utility bills. What is apparent power, active power and reactive power. Let's begin. Power factor. Power factor always considered in AC system and AC circuits, not in DC system or DC circuits. Before understanding the power factor, it is required to understand the power load and type of power. The type of power. There are three types of power. Apparent power, KVA, active power, kilowatt, and reactive power, KVAR. Similarly, there are three types of load. Resistive load, which is pure resistive, like bulb, you're pressing iron. The inductive load, it's like a winding in the equipment as a fan, as a motor, and the capacitive load is a capacitors in the equipment. To understand the power analogy, consider fresh apple juice. Suppose you bought a fresh apple juice and it is including with foam. So the total juice can be said as a apparent power, and the true juice and the real juice can be considered as active, real or true power, and rest of the foam, which is a reactive power. The foam is useless, and similarly the reactive power cannot be used and it is useless. Now consider the three types of power: the apparent power KVA, active power kilowatt, and reactive power what is called KVAR. The apparent power comes from source. It can be grid or generator, and it's considered as a KVA. The rating says a KVA. Active power. Active power is what like a real juice, what we consume by factory, buildings, or any load, the real load. The reactive power. The reactive power is not used, it is a part of the load. So the apparent power is a combination of active power and reactive power. Now consider the triangle of power. As per Pythagoras theorem, the apparent power is a square root of P square plus Q square, active power square plus reactive power square. Now understand the load. The first load, pure resistive load. In pure resistive load, the angle between voltage and current are same. In other words, the voltage and current in same phase. Now consider this graph of voltage and current in pure resistive circuit, where the angle between the voltage and current are same. So the voltage and current are in same phase. So power will be the product of voltage and current and always remain positive. See the graph, the power in green line, where the power always remain positive. Now consider the circuit of pure inductive load. In pure inductive load, voltage leading to the current and current is lagging to the voltage. See the graph where voltage is leading and current is lagging. In pure inductive load, the product of power sometimes goes to positive and sometimes goes to negative. The negative portion of power is said to be reactive power. See the green line. In the green line, positive portion is active power and the negative portion is reactive power. Now consider the circuit in which there is a combination of resistive load and inductive load. Voltage is leading and current is lagging. See the graph. The current is lagging and voltage is leading. See the green line where some portion of power goes negative and higher portion of power is going positive due to the combination of inductive and resistive load. The positive portion is active power and the negative portion of power is reactive power. Combination of resistive and inductive load, higher portion of power is active power and the negative portion of power is reactive power. Now again come to the analogy of apple juice. The total juice is apparent power which supplied by the source. It can be grid or generator. The active power is the real juice which is consumed, and the reactive power is the form which is not consumed. The form is a reactive power. If the reactive power is less or minimum, it will be good, or it also defines the quality of load. Power and load summary. Apparent power is a combination of active and reactive power. The power which remains positive and consumed is called active power. The power which is not being used and oscillate back and forth is called reactive power. Pure resistive load doesn't generate reactive power and apparent power KVA. Active power is same as apparent power in pure resistive circuit. Inductive and capacitive load generate reactive power and it goes back to source. To determine the quality of load, it is required that apparent power should be utilized effectively and that efficiency is power factor. Therefore, the power factor is the ratio of active and apparent power. Now we know what is a power factor. The power factor is the ratio between active and apparent power. In other words, we say power factor is the ratio between kilowatt and kVA. So, the kilowatt is the product of power factor and kVA. Now consider the triangle of power. The cosine angle between the active power and apparent power. So a power factor. There is another definition of power factor. The cosine angle between the current and voltage is also known as a power factor. Now consider the three loads: resistive, inductive and capacitive. In resistive circuit, the power factor always will be unity. In inductive circuit, the power factor will be lagging. In capacitive circuit, the power factor will be leading. Now we will learn about the characteristics of power factor. Consider the power factor meter. If power meter shows to lagging, we will say it is inductive load. If power factor meter shows towards leading, we will say it is capacitive load. If it shows towards unity, we will say it is pure resistive circuit. Best power factor is near to unity. Good power factor is from 1 to 0.095. Poor power factor is from 0.95 to 0.85. Bad power factor is below 0.85. Bad power factor also increases the electricity bills. Now we will learn how power factor effect can be reduced. In other words, how the effect of power factor can be reduced to minimize our electricity bills. Let's suppose we have a circuit of combination, inductive and resistive. In this case, the power factor towards lagging. It is required to shift it towards the leading or unity. We need to add capacitor. See a circuit of combination of inductive and resistive load. If we add a capacitor to the load in parallel, the power factor will be shift towards unity or towards leading. In this way, we can reduce the effect of power factor or improve the quality of load to minimize the effect of power factor on our electricity bills. So friends, if you like our video, if it is informative, so please like and subscribe. We will share more informative videos in future. Thank you.